Welcome, everybody. Hello and good morning. And welcome to this session on an international perspective on next-generation implementation and operation. My name is Michael Pröstler. I'm the CEO of GridGears and also Vice Chair at the TechOps Committee at EENA. We have great guests here today. They've come a long way, traveled from the US, and please give me a minute to introduce them to you. We're going to kick this off with John Snapp. He's the Vice President of Technology at Intrado Life and Safety. And he will provide us some insights what it actually means of managing and operating a next-generation emergency service IP network, an ESInet. And then we have the second presentation by Shannon. He's the Interoperability Program Manager at NENA 911, and he will focus more on the security aspects and the interconnectivity and interoperability between multiple ESInets. So before we get started, please put your hands together and give them a warm welcome. All right, John, the stage is yours.
Thank you very much, and good morning, almost afternoon here for everybody. So I'm going to talk a little bit today of some of the ESInet implementations that we've done in the US, a few of the lessons that we've learned, a few of the challenges that we've had and such on the deployments. So in the US where we have today, so far we have a total of there's about 5,700 PSAPs that are within the US in the entirety that we're trying to look at covering. We have, so far, the ESInet deployments have done quite well in the US. We've got over 244 million people that are either covered or in the process of being covered with ESInets across the US for next-generation 911 networks. With the total population, we have about 330 million in the US right now. So we're doing that through about 42 of the states, I believe are the ones that we have listed that have started deployments or are in the process of doing deployments. And with that, we get a lot of the challenges that we have 7 or more companies that are doing those deployments. So we're experiencing today very much of the interoperability between ESInets and the handoffs between ESInets and how that will actually be done. For us ourselves as Intrado, we're a provider of different services, working with carriers, working with PSAPs and also ESInets through ourselves directly and with our partners. And so through our partners and with us, we've deployed ESInet services or are in the process of deployment or under contract form to cover about 34 million of the population in the US. So what was it before we started to do next generation 911 in the US? What was it? Very different from how it was done here in Europe. In the US, we have a system that was deployed starting in the 60s, and much of the technology we have that's for the legacy 911 network is still from that era. Very ancient, very old technology. But very, very complex that we had to deal with that's in place today. It's pretty much a dedicated network that's out there, separate from the normal PSTN, may use some of the same infrastructure along the way, but effectively different. We're bringing, it was designed originally for wireline telephones, as we had to sort of kludge it together to make it work for wireless telephones and VoIP, and as we had local number portability, we had to really kludge the network to make it work for that. So we sort of had multiple technologies coming in, and then going to the PSAP, we had multiple technologies over this somewhat dedicated network to deliver the call and provide location information. For wireline records, it would be name and address. For wireless, we've always had carrier-provided network location, and then more recently, handset-provided location, providing that down to the network. The technology oftentimes to the PSAP was a very old technology on delivering the calls. It was called CAMA. It was designed in the 60s and the 70s for talking between offices to deliver information about who the caller is so they could bill for the calls. And that's still in there today, and very low-speed data links for doing the data. So we had to work on how are we going to move from that to a next-generation 911 network. As I look at as we're moving to an end goal, and this is really the simplified version of an end goal, very much like being done here in Europe, to get us to a simple model where it's a SIP-based communication from the device all the way to the PSAP, providing location information, other technologies that can run across it. And we're having that, but we want to make sure how we're going to get there. And I look at a lot of this as the most complicated part is not where we're going to be, but how we make that journey to get to the destination. How do we keep supporting our legacy pieces as we do a transition and get us to the next generation? When the first ESInet was deployed in the US, 0 of the carriers were delivering anything new. It was all of the carriers at that point were still delivering TDM type connectivity, the legacy legacy sort of telecommunications connection into the ESInet, and 0 of the PSAPs were receiving their calls over next generation interfaces. They were still using legacy interfaces. We built the systems that are out there for the ESInets to deal with this transition, where we built the next generation in the core and started expanded out to the edges. The big thing was we didn't want to wait for every PSAP and every carrier in the country to be ready for next generation before we could start deploying, or we would still be here on the stage 10 years from now saying we're getting ready to deploy next generation. So this migration and supporting the other technologies allowed us to move toward it when everybody wasn't ready and we didn't have to wait for it. I heard some presentations earlier that we're sort of waiting. We haven't deployed next generation because we don't have sort of all the pieces for doing it. What we've sort of found out is we needed to deploy it now, and we can let the pieces, the PSAPs and the carriers come into it. We can pressure them, but come into it as their technologies allowed. So really sort of the challenges that we had on that really is, like I was saying, it's the transition. It's the migration. It's how we get there more than it is what the end game was. We couldn't wait for all those carriers to be I3 before they're deployed. Now the carriers are moving. In the US today, we have one carrier that's very much deployed on I3 technology or next generation 911 coming into the networks in many areas. We have another carrier that's halfway there, and we have a third carrier that's moving that direction. But the ESInets can support all 3 of that technology. On the PSAP sides, when they're deployed, there's many of the PSAPs that are now next generation all the way into the PSAP, and other ones that have to have gateways and such put in place to convert back to their legacy. But then as those PSAPs migrate to next generation, we can then seamlessly bring them into the network because the core treats it as if everything from the carriers we converted into next generation, and then everything from the PSAPs, it runs sort of a next generation 911 to the edge, and then may have to be converted back to a legacy type connection. So that's allowed us to really kind of move and get there. If we didn't have that, we would kind of be slow on doing it. Double-clicking there. So what did we really need? What are the elements and the pieces that we had to get us to a next generation network? We had the elements that you saw on the slide earlier, which was sort of the simplified model of what we were being able to do, and then we added extra elements. So from the standpoint of this, we have some here that we call the legacy network gateway. And this really allowed us to take legacy carriers, both the voice side of it and the location side of it, and bring that into the next generation network and convert it to next generation before they were ready. We want to get them off of that as quickly as possible. We want that element to go away. We want to retire that and put it into the closet and move us to the next generation. But we put this in here so it converted these different TDM type interfaces and moved it into a SIP, RTP, location network inside of the core. And so what we were doing is we were getting the calls, TDM calls, we're converting them to SIP. We're getting the location over our traditional network that was ALI, the automatic location that was an old interface providing for both wireless and the wireline calls for location. And we're querying that and adding it into the list services inside the ESInet and the PITA flow being passed with location and with the SIP call being passed along and taking additional elements from that ALI database beyond location. We call that the ADR, and we're passing those elements along in the I3. So when it comes out for the carriers, whether they're an I3 carrier or not, the capabilities were the same. What we got as we moved them to I3, we got the advantages of speed, making things quicker, and we got the advantages of simplicity of removing elements from the network. And so then as we move over to the PSAP side, If I hold it slow, I can do it up here. On the PSAP side, we had the same issue. We had PSAPs that were the CAMA type side, and we had PSAPs that may be IP. So we used the legacy PSAP gateway on that side to do the same conversion. So we could deploy, as the PSAPs had the challenges of long contract periods for their equipment, of how often they could do a refresh cycle of their equipment, we would never have been able to synchronize all of those because many of them are operating pretty much on their own of these almost 6,000 PSAPs. So we may do a mix of deployments of a next generation PSAP if their equipment could support it, or we use the legacy PSAP gateway to support those PSAPs that may not be there yet. Also, we may need this as we transfer, if the call comes into a PSAP, it needs to be transferred to a neighboring PSAP. That PSAP may not be next generation also. We had to support those to be able for them to receive the call in the legacy mode where the PSAP it originally came into was a next-gen mode. So that's been the complexity of it. The goal will be, as we move these elements along, that we'll transition back to that pure simplified model of what the ESInet will look like. So here are just a few of the elements just to kind of go through it for folks on the ESInet side. Is we have an element of the ESRP, the Emergency Servicing Routing Proxy. That's effectively in sort of the simplified model. That's our core element for switching the calls in the next generation network. We have the ECRF, the Emergency Call Routing Function, that allows us to do location-based routing and allows us to route it to the PSAP that is appropriate for where the call came in within the ESInet. Things that we've done, I mean, there's some requirements for what we need to make that work, and a big requirement to make that work is getting location quick enough and accurate enough to be able to route the call. In the US, as we're dealing with legacy and we're dealing with next generation, some things that we've done in the US is we've taken the location that we're getting from the device-based hybrid location, the handset-based location from like AML and ELS that are coming in, and location and SIP messaging that we've heard about in some of the other sessions. And we take all of that information and utilize it, and we typically, over 80% of the time, have a location accurate enough, which we say is within 150 meters, using the location and SIP, using AML and ELS. We have that location that's accurate enough to route the call within the network, because part of this is we don't want to hold up the call as it's routed. So that location is now available to utilize these functions, and we can very accurately route to the proper PSAP where it was. In the US, prior to that, all the calls were being routed based on cell IDs. And even in the early days of ESInet, all the calls were being routed based upon the cell ID location of where they are. And with the additional location, we'll be able to route it quicker. We actually implemented that in addition for some of the legacy stuff to help PSAPs that haven't transitioned yet, so we make the routing more accurate, particularly to help us eliminate the need to have to use some of these transfers between an I3 PSAP and a legacy PSAP, or between two legacy PSAPs, or even between two next generation PSAPs. We wanted to get the accurate routing to the best PSAP we could at the time. So as we move, it sort of took us back to, we're trying to get back to this sort of the next generation network of how we're routing. This will be our end goal. So at this point, we're going to be transporting the call from the device through our emergency service routing proxy. We're getting the location information in that's on the list or the location server. We're using the ECRF to do the routing and routing it to the PSAP, getting location information, and then we start removing all of those other elements that we had. We'll be able to remove the elements of the legacy network gateway, and it can go away. And we have a very simplified model on the left. And as the PSAPs move, we're going to remove the legacy PSAP gateways on the right, and there will become a simplified model. Which one will we remove first? Don't know. Would have thought it would be on the carrier side. Very much might be the PSAP side. It will be the ones that move there the quickest. So the part I talked about a little bit earlier was also about location-based routing. And I think this is one of the biggest advantages that we get as we move to a next-generation network, is the core routing capabilities within that to route the calls based upon location. reroute the calls based around location and how it may be utilized. We've already started seeing areas in the US starting to use this type of a routing on the core network to route the calls based upon events or small geofences that we may be using inside the ESInet, where the idea is we may have a large sporting event and they can route those calls uniquely for that event dynamically at the time and route those calls to a very specific location, either a series of call handlers inside that PSAP or to a specific PSAP or emergency command vehicle that handles the calls in that area, so they get very location-specific, contextually aware of where it is. And so having those elements allows that to be done on routing it. In areas we route the calls that, we found it very accurately in some of the early ones that we've done, is we can route the calls very accurately. If it's on the highway, we may route it differently to a different PSAP that may be a highway patrol or a state police, and we can route it directly to that center, that PSAP, to handle that call so it doesn't have to be transferred. We tended to see by using this precise location, our transfers have dropped dramatically on what we've had to do in many of the centers we've been able to work with. And in the past, everything was sort of a tabular location. We said this cell site routes to this PSAP, and this cell site routes to this PSAP. Doing it in a graphically type method using that, the routing function in the network allows us to move away from that and have it simplified. Unfortunately, we still always have to deal with cell site locations, so sometimes with those, we're on borders. If we have a cell site location that's covering a highway and another area, we have to pick which location that's going to route to. So it's still not 100%. We're working towards there to get better and better on sort of the routing pieces of it. Another part that we've done as part of the next generation network in the US has been text to 911 also. We've talked, I think there's a session here beforehand, we were talking about RTT that's also been deployed. But text was really one of the first things that we deployed in the US for next generation. It was done before we really had next generation networks out there. It was built on an architecture of next-gen 911 using the same routing elements that we had in the networks I showed before, and it seamlessly plugs in to the next generation networks. What we have for the elements of how we've done this in the US, and it's worked pretty well. There's operational challenges inside the PSAP side, particularly for the length of time it takes for the call to be handled, which are challenges that hopefully technology will start to overcome. But what we've done is on the carrier side, there's an element called a TCC, or a text control center. And this element is effectively a protocol converter. It takes text messaging from being SMS or MMS, which may be pictures, media of types, and multi-party, or it can take other types of interfaces. We've done it from over-the-top applications that may be having a text interface. So it really could be any user-to-user type communications that you may have, and it converts it into a SIP stream effectively that will flow through the next generation network and allows it to be routed. We utilize location in there for being able to do that. The location can be, in the US, we get a carrier-based location, which could be a cell-based location, or it could be an accurate GPS location. We're also getting sort of the next generation of it is on some of the devices, we're getting location with the SMS message over, so SMS over IP or 4G IMS type SMS location. We actually have the location embedded with each individual message that we pass along. So it's very much like on the voice side, where we have a SIP call with location that's coming across. We're having SMS calls with location coming across. We also are utilizing AML and ELS. I will say in the US, the only version of AML that we utilize within the US is the HTTP version in general. We're not using much of the SMS version. We use it a little bit as a backup, and the majority of the AML that we're using there is HTTPS, but every carrier in the US right now that I know of is utilizing that, and utilizing that sometimes for routing and definitely for delivery to the PSAPs. And so for text, we can utilize all of those same location sources that we had for voice. We have the AML location with ELS, we have PITAFlow location, we have the network provided location from the carrier. And so we utilize that on the TCC just like a voice call to do routing to where you may need to go, to which PSAP does it need to go. And if we kind of do parallels with this, so one function of SMS that is causing a challenge always, sort of utilizing of it, is with SMS, it always goes to the home carrier. And so with utilizing this, it always goes to the home carrier, but we're also able to get location from the home carrier. And we route this to wherever it needs to go. If I look at parallels with Europe, each ESInet could be a different country. This can be utilized to actually route to the countries, supporting a roaming environment to be able to sort of using text location. Sort of finalizing up is really what were our challenges here. It's really, we have to be able to support the different levels of capability on both the ingress and egress to allow us to deploy this and deploy it quicker as we can. Again, migration is 90% of the effort. The endpoint isn't so hard, the technology isn't so hard, it's not so complicated, it's how we get there is always the challenge. We started by, of course, keeping the next generation or the i3 in the middle and then moving towards the edges of those capabilities. We had control of the middle, we didn't have control of the edge, so it allowed us to move this and really implementing it. It allowed it, the challenges of implementing it, everything in the US was built on tabular data before, and so we moved it more to a GI space. That was challenging on getting that information from a lot of the jurisdictions and converting that information to a geographical method. Having this precise location, really this geo routing wasn't a capability until we had that precise location. So that was a big game changer on getting more accurate routing through the network. And the next part that's really going to help, we had a challenge a little bit routing between ESInets because we don't have the concept of the forest guide. Brooks is going to talk a little more about that. That is another game changer that's going to be there to allow the intercommunications between ESInets and initial routing to really simplify it so every network doesn't have to maintain their own, effectively create their own forest guide. We have a national forest guide to be able to use. That will help us work. We've had challenges with interoperability between ESInets, but we're really solving that. And sort of the redundancy, how you build that model, what you may use, and so on. And we'll also, challenges that we have will be another one Brooks talking about, certificates. And so that's another one that's finally coming, and we're getting challenges about that and how we're going to sort of solve that. But thank you very much, and I'll hand this off to Brooks.
Did you want to ask a few questions?
Thank you, John, for your presentation. I think before we get into the presentation from Brooks, are there any questions from the audience? Oh, I see one.
Yeah, thanks for the presentation, and thanks for the insights how it works in the US with regard to an ESInet and deployments. I have seen two things. I would like to ask two questions. The first is, I've seen that rich communication services on the operator side was on one of your slides. Do you see this as being also a solution for accessibility, or will this be all replaced by real-time text in the future? Yeah.
So you may comment on too. For the RCS, we haven't implemented any of those effectively for the disability for text. We've had, I would say, some over-the-top services that were close to that, but not ones coming from carriers directly. But I see that by having something like the TCC that we do, that's that protocol converter, whether they come in natively to be the solution where they plug directly into the next generation network using SIP, MSRP is the protocol, or whether they have to go through the protocol converter, it allows us to support any of those. The only requirement is we get the messages coming in, and we have some location method of some degree, and then again, we don't have to wait for each end. It converts it to what the PSAP needs, and it converts it to what that communication services need. And that seems to be doing pretty well on getting the text, getting that types for the disability. The most of what we're seeing of communications for the deaf and hard of hearing community coming through right now is using SMS. We have a hard time knowing that for sure, but sort of anecdotal evidence of where people are saying things and reports from some PSAP, that's where a lot of it is. We've deployed RTT in some areas. The carriers have fully deployed it. they convert it, it's deployed completely to PSAPs from the standpoint of getting messages through. A majority of them are coming through converting from RTT to TTY. And we don't have a lot of PSAPs that are supporting RTT natively yet. That's being built and is being deployed. But we haven't seen a great adoption of that. It's been the challenge from the user standpoint.
Thanks. The second one, I've seen that you had some challenges in interoperability between the ESInets. Just wondering if you have the I3 standards document, you have the specified interfaces, the specified components, core services. What kind of challenges do you have then actually? If everyone follows the standard, is there a lack of conformance testing perhaps?
It's sort of the standard of interoperability for it. If we take the I3 spec and hand it to 5 people and sit them in a room and tell them to write the spec to talk out, each of the 5 people will have a different implementation that won't talk to each other. So as we've developed network interface specs for each of the different ESInets, we work together between the ESInets to say, which headers are you needing? How are we doing the messaging? And in creating somewhat an interoperability between the different ESInet providers. It hasn't been overly difficult to do that. It's just the first time it never quite works, and we have to work it. But it's very easy for all the folks that have been involved to manipulate what we need to make it work. I mean, there's always been challenges of connectivity and DNS, DNS issues and certificates and such. And so there are little stumbling blocks that haven't been the biggest challenges.
Okay, we got another question. I think we have time for a short one.
Bertek, Swisscom. Do you use location by reference in your SIP? And when do you use location by reference? Who gets the reference? Is it the voice service provider or is it the device?
So we typically so the answer would be it depends. In general, I'm going to talk about the mobile calls. So for mobile calls, we use in general so I'll say for our network, we use location by reference. We're passing that through because we always want to have the ability to be able to do updated location. The location server that we're sitting there, the list that we're querying, it could be inside the ESInet, but the location is coming from the carriers. So so in the US, with being a little different, the carriers are completely responsible under FCC regulations to provide the location. They may be doing it through ELS or AML or through SIP messages on how they're providing it, but effectively that's the regulated side of it, and so they're sort of getting that location and putting it together into their list to provide that location on the wireless carrier side. And so we're getting it there. We often use location by value also. And the reason for that is what if that list server is down? What if that connection is not available? We want some backup method to make sure we can route it to the right PSAP and not have a failure of it. So it's a big part of using both of it. We're using it by value explicitly as a value in there, or we're having some other item inside the SIP message that allows us to make sure that if the location by reference fails for whatever reason, we still have a method to get it to the right PSAP, because if it's coming in to an ESInet that covers the whole state, you have no location, who do you send it to? Who's the one that would answer that call? We want to make sure that default routing always has some place that can handle that call.
Okay, thank you very much. I think we're running a little bit out of time, but I'm guessing John is more than happy to answer any questions. Is it a short one?
It's quite short, yes. It was just on the funding and the financing of the whole ESInet, and is there a regulatory push behind it, and how is sort of the setup of the arrangement?
I mean, who's paying for what?
For the ESInets
Yeah. So in general, the demarcation point is, if I've had the picture up there, the demarcation point where it comes into the ESInet, up to that edge is the responsibility of the carriers, and the ESInet all the way to the PSAP is the PSAP community in general. It may be a state, it may be local areas, but that's sort of the responsibility of the public safety side.
Okay, perfect. I guess John is more than happy to answer any questions after the session. So, Brooks, We're looking forward to your presentation.
Thank
and the stage is yours.
Great, thanks.
Well, thank you. That was a great presentation, a great survey of next generation 911 architecture and I3, so thank you, John, for that. What I'm going to do is talk about some fundamental parts that John kind of alluded to. One was the forest guide, and one was this use of certificates to secure communication within and between ESInets. I'll talk about what we call the PSAP Credentialing Agency, as well as the forest guide, but this is under the auspices of something called the NIOC. I work for NENA, the National Emergency Number Association, but part of my day job is supporting this thing, the NIOC, the NG911 Interoperability Oversight Commission. So we'll talk about that today. We'll talk about what that Oversight Commission is and what makes it special, why it's different from NENA. We'll talk about the PSAP Credentialing Agency, what that is. We'll also talk about the Forest Guide, and I'll give a status update and share some next steps about those things as well, because they are in the process of being implemented, and I'll talk about where they are today. So let's first talk about the NG911 Interoperability Oversight Commission, the NIOC. What is that thing? Who is it? It's an independent, transparent, revenue-neutral organization established to oversee security and interoperability in NG911 communications. It is its own thing. It is not part of NENA, although NENA helped set it up. It has transparency. It is also revenue neutral. Its bylaws forbid it from making money, and that is on purpose, because it's to serve the entirety of the community. It was created, first and foremost, to stand up and operate the PCA, the PSAP Credentialing Agency. That's the private PKI for NG911, as well as to operate the Forest Guide. Because, absent a PKI, there's no trusted communication among NG911 systems, much less inside of an ESInet. Absent the Forest Guide, there's no complete interoperability between those different ESInets. We talked about the fact they could be states, they could be regions. How do you communicate between them? If you try to send a call from California on one coast to New York on the other, how do you do that? The Forest Guide can help. If a single entity oversees both, we get economies of scale. The overall cost is less, and there are greater operational efficiencies. So who does the NIOC represent? Its composure is made up of entities that represent the public sector as well as the private sector, and non-voting liaisons such as the United States FCC, Federal Communications Commission, Department of Defense, the Cybersecurity and Infrastructure Security Agency, and many others. So we try to have a good composure of different stakeholders within the next generation 911 framework. In fact, one of our voting liaisons is the CRTC from Canada. That's a big deal because the Canadians implemented next generation 911 using the NENA I3 standard nationwide. That's really cool. So let's talk about the NG911 interoperability services. That's kind of our umbrella term for the Forest Guide and the PCA. Interoperability in NG911 is ensured by standards that standardize interfaces and that standardize data structures. So we have this whole stable of interfaces on the left, and we've got some data structures on the right-hand side. You have to standardize those so you can take your data and shuttle it across the wire and have the other side understand it. But there's these other elements that we'll talk about today, again, the Forest Guide and the PCA, that ensure not just interoperability, but secure interoperability between those networks. So let's talk about the security part first, the PSAP Credentialing Agency. We'll talk a little bit about the PCI and what PKIs are. Does anybody in the general audience know what a public key infrastructure or PKI is, or know what digital certificates are? Awesome, good, good. But we'll break it down for the folks that may not be as familiar. So generally speaking, we like to say NG911 has trust issues. Even mundane transactions using IP require a secure connection. Sorry. How do we back up? There we go, okay. Modern security utilizes something called a zero trust framework. We don't trust anybody. Even if you have a collection of functional elements and computers that sit within an ESInet, we don't want to trust those just blindly, right? We want to have a third party that is vetted and trusted essentially help us trust them, right? We want to have this impartial third party that can vet that they are in fact trustworthy. A PKI establishes that chain of trust. You have a root certificate at the very top, and all certificates issued from that descend from that root. So you can trace it back up to the top to figure out if you're trying to talk to somebody, does their certificate come from a trustworthy source, the same trustworthy source as my certificate? The PCA is what we call the root certificate authority for NG911. That is that singular offline root certificate that all other certificates in NG911 will descend from. And the NIOC is establishing that PCA so that we can fulfill the needs of the I3 standard and so we can ensure that the communications that happen inside of an ESInet, in between ESInets, can be trusted. NENA staff, me, support that along with a few others. We like to say in NG911 there is no trust. Again, it's that notion of zero trust. You have a lot of elements that might sit in an ESInet. A vendor, for example, may provide those as a managed service. They could be things that a 911 authority procures themselves. Those things should use TLS and mutual authentication inside. You shouldn't use self-signed certificates or anything like that. We should take the kinds of security that we would use between ESInets and still bake it inside of our own, right? We shouldn't just blindly trust those elements. Maybe somebody's doing something malicious. So that's why we have this root of trust, the PCA. So what does it mean for entities that are standing up and maintaining NG911 systems? It allows those elements to trust one another. So on the left-hand side, if you live in the great state of Minnesota, where I once lived, and you need to transfer a call across the border to another great state, Wisconsin, Wisconsin can trust who you are because it can get your certificates and it can trace them back to its same root of trust, the PCA. You don't want to just blindly assume that you trust that entity, and you don't want to do it inside of your ESInet as well. This notion of shared trust and also authorization is permeated all throughout the NENA I3 standard. So this really supports that standards-based security and interoperability. Every system ultimately needs certificates anyway. When you log into your online banking application to see how much money you have, you log into a utility site to pay your bills, that's all protected by certificates. That's that little padlock you see at the top by the URL bar. We need to have those certificates anyways. Let's have special certificates for NG911 that can assure that trust for us. So generally speaking, if you remember one thing about PKI, trust nobody. Don't just assume trust, especially if someone tells you they're trustworthy. That's a little suspect. Always check with a third party to establish trust, and do that using a vetted source. That's what we're setting up at the NIOC. So let's next pivot, and we'll talk about the Forest Guide. This is near and dear to my heart because I've written a few of them as a software engineer myself. So I'm very happy to be able to work on this project. Why do we need a forest guide in the first place? Why do we need something that sits at the very top and understands where other ESInets are? So you can have interoperability between those ESInets. The forest guide provides routing instructions between disparate 911 jurisdictions and disparate ESInets. That might be between states within the United States or large cities or regions. It may be between countries. And in fact, it will be between countries. It is based on standards that not only come from NENA, but also the IETF, the Internet Engineering Task Force. And it's done that way because, as much as we would like to, not every nation is going to use the NENA I3 standard, but if they use the standardized location-based routing protocols that come from the IETF, this will work. Really what it's meant to do is it's meant to resolve queries about locations that are outside or originate outside of their intended location. Again, if we use that example of a 911 call being placed in California, but it's really on behalf of somebody in New York City, that PSAP in California should be able to transfer that call very seamlessly all the way across the United States to New York. How does it do that? It ultimately contacts the forest guide to say, where is this location? Where should it go? And the forest guide will say, talk to this other ESInet, talk to the one in New York. So let's talk a little bit about that. So as John talked about, in NG911 we used GIS data and location to route calls. It's easy if you're all within one ESInet. A location comes in from the salmon-colored box, that's going to go over to PSAP 2. Comes in from the northwest corner, the little jurisdiction up there in yellow, that's going to bounce over and go to PSAP 3. You take the location of a call and you drop it inside of those boundaries, and that's how we route the calls. But how do you then route between countries? How do you get a call from the United States to Canada, or vice versa? We're starting to see this happen more and more in some interesting and creative use cases. I was recently contacted by a 911 PSAP manager in Buffalo, New York. And she said, I'm trying to figure out how to contact Canadian PSAPs because we had somebody here in Buffalo dial 911, and he said that he was from Quebec City. And we have no idea how to contact Quebec City. He said that he had a security camera app on his phone. He was traveling. He was in Buffalo. The security camera app went off and showed that there was somebody, a burglar, breaking into the storage warehouse that he owned for his business. Not knowing how to contact Quebec City himself, he dials 911 in Buffalo, New York, and they had no idea how to contact the Canadians. This fixes that in Next Generation 911 because that call taker could enter in the location of where that is in Quebec City, hit a button, and the network will end up going up to the forest guide, or down in this case, I guess, at the bottom of the trees, to see where that location is. It would hit the United States forest guide, and that forest guide would say, it's not in the US, but I know where it is. The Canadian forest guide knows, and it will redirect automatically to that, helping those elements figure out which network to talk to. That, of course, can happen globally, and that's precisely what the IETF envisions, is that there would be a global network of forest guides that exchange data automatically between them. There's a protocol for that called Lost Sync, so that if you had someone who lived in Slovenia and they traveled to the United States and their grandmother calls them and says, she's fallen. Grandma didn't call 112, grandma called her daughter. What does that daughter that's on holiday in the US do? She dials 911. How do you get that call back to Slovenia? You do that through a global forest guide network. And that is why we are standing up our own in the United States. So let's talk about status updates and next steps. First and foremost, a lot of this has been tested already. Here at NENA, we do these things. They're very similar to the ETSI-EENA plug tests for NG112. They're called ICE events, Industry Collaboration Events. And what these things are is there are interoperability testing events where vendors come to the table with all of the different widgets and functional elements they have. They plug them together and they run through testing scenarios and they figure out, do these things work or do they not work? Because not everybody interprets the standards the same way. As a developer, I did not interpret the standards the same way other engineers did too. So it's really important for us to have interoperability tests like this, especially for new emergent standards. We want to kick the tires on the new stuff. We want to test the things to make sure that there are no errors in the standards, that the standards are easily understood, and there are no ambiguities in the standards. Since ICE 9, we just finished ICE 10, so ICE 9 was held in 2021, we've worked to test not only the forest guide, but these certificates from the PSAP credentialing agency, the PCA. ICE 9 was the very first time we tried to test those certificates. We learned a lot. We learned that really a lot of the folks in the vendor community are not used to working with them at all. So it was kind of lit a little bit of a fire underneath them to better understand how these things work and how to properly utilize them within Next Generation 911. Importantly, ICE 9 also tested international emergency calling scenarios. We worked very closely with Wolfgang and others to ensure that we had collaboration with the 4th NG112 plug tests event to actually place calls on one side of the Atlantic Ocean and route them, transfer them to the other side, using those scenarios that I recently talked about. We proved that that worked, and it was the first time we had, which was incredible. With ICE 10, we primarily tested new emergent interfaces that were released with the version 3 of the NENA i3 architecture standard for NG911. But we baked in the Forest Guide as well as those PCA certificates so that they became foundational elements within the testing because they are foundational elements to next generation 911 and security and interoperability. Future ICE events will continue to leverage those certificates and exercise them even more because there are some things inside of the certificates that also express like the role that a service or element may have, or even if you're credentialing a human being, what role they have. Are they a call taker, a dispatcher, a supervisor? Where do they work? The functional elements within next generation 911 can inspect those things and can change their behavior based on it. You could have a call handling system at a PSAP, look at that certificate and say, this person is a call taker but is not a dispatcher, so I will not let them do dispatching things. And then if that person started working at or for or on behalf of another PSAP that maybe is no longer functional, they're providing relief support for them, the software at that PSAP, utilizing that very same certificate, because it adheres to the standards that we have developed, will be able to do the very same thing. Let them be a call taker, but not let them be a dispatcher. So that notion of having certificates as well as the Forest Guide is very fundamental and will be part of every ICE event moving forward. So let's talk about the status of the PCA itself. Where are we at today with this thing? The NIOC is open for business and we're looking for subscribers. The way this works is that entities that operate ESInets, again, usually states within the United States, but sometimes regions or cities, they will subscribe to the NIOC's services so that they can create and issue certificates from that root certificate, the PCA. Many of the states may actually work with their NG911 system providers to do that on their behalf. That's probably what's going to happen, but you may have states that decide to do it themselves. We're still figuring that out. We are not going to start production and sign the root certificate until we have at least one subscriber ready. I'm happy to announce that we're pretty close there. So close, in fact, that we are going to issue the root certificate and sign it next Thursday. This has been years in the making. I remember talking to an organization back in 2014. They were starting to get into NG911 and they said, well, there's no Forest Guide. There's no PCA. We can't do it. That's what everybody's been kind of faced with. We're here now. It goes live next week. That's a big, big deal. And I'm very happy to report that. The Forest Guide is a work in progress as well. Our vendor for the Forest Guide happens to be on stage, Intrado, and they are hard at work in getting that thing ready for production use as well. It's going to be ready on September 13th, 2023. And by ready, it means that ECRFs at a top-level ESInet level, like a state, for example, or a large city, they will be able to connect to it, they will be able to submit their data to it, their coverage data, and we will start that process of interconnecting and interworking through the Forest Guide. Very, very excited about that. That has been a long time coming as well. So what's next? We are continuing outreach efforts to make sure people understand what the heck these things are, because they're a little on the fringe, they're a little esoteric and weird. Not a lot of people really understand them, but people will need to, especially the PCA, because when it comes time to start vetting PSAPs and start vetting the professionals that work at a PSAP, local entities themselves, like a human resources department at a county, will be involved in this. Nobody's prepared for this. So we have a webinar coming up that we're going to start shedding some light on these things with. We have outreach efforts at our annual NENA conference. We will be talking a lot about this, and we will have a lot of additional things coming up to help educate folks about this, not less the Forest Guide as well. We're engaging with federal partners too, like the United States Department of Defense, to make sure that PSAPs on a military base can contact their neighboring civilian bases and have that chain of trust established between them. Further on the horizon, we want to explore international collaboration. Canada is probably a natural place to start because it borders the US and they are using the I3 standard. But if some enterprising folks within Europe were to stand up a Forest Guide, we could interconnect those as well. So I want to leave on this. I've got one more slide here, but I would encourage you, if you want to learn more about the certificate stuff, the PCA, snap that QR code. We have a webinar coming up on May 8th. It is a little late here in Europe, but it will be recorded. It's free and open to the public. You don't need to be a NENA member to access it. And it'll help you understand, PKIs a little bit more, It'll help you understand why they're important. It's not just the standards. We want to actually have security. And it'll help you understand where this is all heading and what the implications are. So today we discussed what the NIAC is, why it's important, why it is not NENA, and why it is transparent and revenue neutral. We talked about the purpose of the PCA. It's not just because the standards say you need it, it's because we want security, and we want secure interoperability between networks. And we talked about how the Forest Guide supports interoperability through being able to access resources and transfer calls across ESInet boundaries. We also shared a little bit about what's in store for the future. So with that, I will yield the floor. Thank you so much for the opportunity to share this with you, and feel free to ask any questions you may have.
Thank you, Brooks, for your really interesting presentation. Do we have any questions from the audience? Don't be shy, this is your chance.
I figured Wolfgang would have one.
Yeah, thanks, Brooke. Great presentation. So actually, Freddie and I, we were wondering how to get this deal done in Europe. So I think we also need a Forest Guide and a PCA, but we are far away from signing something.
Yes.
Do you have any best practices or any recommendations for us how to start this?
It's a really, really great question. You know, how would you do that in Europe, right? And in many ways, we do not have best practices established yet because we're not only sort of painting the train as it's moving down the track, we're sort of building the train before we even paint it as it's moving down the track. We're learning a lot of this together with our vendors, with the partners in the industry, with the 911 authorities themselves, which means now is a great time to start talking about those things. Right? I think we kind of know how you could do a forest guide. You could have an EU forest guide that understands the coverages of all of the different NG112 ESInets throughout Europe. There's a lot of questions around funding, who operates that forest guide, all of those things. Nothing says you couldn't have, you know, individual country-based forest guides as well, like a German forest guide and a French forest guide, Austrian forest guide. The certificate stuff is much more interesting. Certainly questions around who operates that, who manages that PKI, who governs it. We would have to talk about this notion of cross-signing the roots probably so that the United States root certificate can trust the European root certificate and vice versa. So there's a lot of questions around that. But now's the time to start talking about that because that kind of stuff can take a long time to establish. The other point that I'll make is that because the NIAC is transparent, if you go to the NIAC website, ng911ioc.org, we have a library page that has all of our policies, including our financial model, the bylaws, meeting minutes, all of those things. But importantly for the PCA, it has the certificate policy, the certification practice statement, and the validation policy. Those three things kind of act as the governing documents for how this PKA works. And I would really encourage anybody that's interested in kind of getting into this stuff in Europe to review those. They're a bit lengthy, but that will help you understand how all of this works.
Yep, thank you. Any other questions? I have one for you. So you talked about the certificates and that once you receive a certificate as a vendor, you're getting access to the ESInet. Are there any mechanisms that restrict which elements I'm getting access to? So once I'm getting access, can I just, query an ECRF, query an enlist, or sending a call to an ESRP, or are there any restrictions?
It's a really great question, and there are. So in the standard, right, the standard will be able, the I3 standard dictates how those interactions occur and dictates the structure of the certificate so that you could, in theory, deny or allow a requester into your functional element or into your network based upon their identity that's inside of the certificate. Or if they don't have a certificate at all, or if they do something that's really suspect, like they just get a commercial cert from one of the online certificates, like GoDaddy or something, you could choose to deny that, or you could choose to rate limit those queries. So maybe you stand up your own location validation function, and you let like anybody hit that thing to validate locations, but you give preference to the ones that have certificates that are traceable to the PCA and have a role that you allow to query.
Oh, thanks.
Yep.
All right, if there are no pending questions, we got a question.
exploit the opportunity to ask you while you're still there. It's just very interesting presentations from all of you, and just on the PCA and the certification topic, very interesting. And can you elaborate a little bit more on that in comparison to the stir shaken solution? Do you reuse some of that, or is it just a totally new or that you have created yourself?
It's a great question. Thank you for asking that. So stir shaken is used in order to ascertain the trustworthiness or the attestation level of incoming calls, right? Is it a hoax call? Is it a spoof call? Is it one that we trust, right? So we certainly interoperate with stir shaken because we want to be able to look at that attestation level when calls come in, and we want PSAPs to set an attestation level when they make outgoing calls. That way somebody doesn't think it's a suspect call when it's actually a PSAP making the call, right? So there are some elements that are being literally defined right now in the i3 architecture working group that will sort of act as a bridge, with one side being stir shaken and the other side being PCA. And there's this notion of transitive trust, and this may not happen, it's very much up for debate right now, but there's this idea that you could say, we trust this attestation level, we trust the PCA cert, we're good to go. Or on the outbound call, we trust this PSAP certificate, therefore we can assign or use a stir shaken certificate that is kind of mapped one-to-one to do that. So more to come on how this actually works, but that is a hot topic right now.
Okay, then thank you, gentlemen, again for your presentations. I think you earned yourself a big round of applause.